So I'd like to show you how to break a problem down into smaller steps. Frequently I tell you this is how to eat an elephant, okay? And there's an old joke about how do you eat an elephant, a bite at a time. I really want you to think about your problem solving and your programming in a step-by-step incremental approach, because if you break it down into very small steps and then test those, you'll be much happier, because when something doesn't work, you won't wonder what's not working. You'll be able to look and see, and it won't be as frustrating for you. And when it's not frustrating, you'll feel more successful, and that's a good thing. So I'm just going to start by writing you a little description here on the side of what we're going to do. Okay, so I want a program that will start when the operator presses a button. Okay, and then I want it to move a parts carrier until the controller sees a value of, let's say, 10 from an ultrasonic. Sensor. Okay, once it does that, I want the motor to stop for 3 seconds to allow for the part to be unloaded. Okay. Then I want it to go back to, the carrier is going to move back to the ultrasonic reads 15. Okay, those match predetermined locations for us. All right, then I want the carrier to, the motor to stop. Okay, and then I want it to wait until the operator presses the start button again to represent, how do we want to say that, that another part has been loaded. Okay. All right, so let's look at what that's going to look like. Every program starts with the green element. Okay, and now I want to start moving a motor, and let's say that I've tested to be sure that clockwise is the correct direction, until my ultrasonic sensor reads a value of 10, I said. Okay, the ultrasonic sensor, the value decreases as it gets closer to something. So smaller numbers means a shorter distance. Right, now do I want the digital branch or do I want the analog block branch for an ultrasonic? The answer is I want an analog branch. All right, so I have that set up, let's say in I1. I'm going to go to my test interface and go ahead and change that to ultrasonic. Okay, and then I want to save when this is, today I just want to show you how, sorry, increment. Another video was getting ready to deploy in the background. Okay, when that was equal to 10. So I can change this condition to be equal and 10. Okay. So if it's no, I just want it to keep going. Alright, I left something out. I started the program with it moving, okay? It didn't start when the operator presses a start button. That's not really a big deal. I can go back and put that in. let's start with, for the moment, alright, that I just want to test this part. I'm going to test the part where it says move a part carrier until the controller sees a value of 10 from the ultrasonic sensor. So I'm just going to stick it in my red man. Okay, so if I were actually running now, I'd start my program, I'd see what happened, and then I would adjust this very small piece of programming, okay, while that was working. When I test this program, I would have my test interface open so that I could observe what's happening here. Alright, let me go also right here and change this to be a ultrasonic. Okay. Alright. So now I would test and see how that goes. When I have that successfully working, I would go back in. Alright. And now look, it says program starts when the operator presses the start button. I should have already put that in. But I'm going to slide this stuff down. I'll just delete that line. Okay. And I put in a start button. So is that digital or analog? It's digital. Okay. And let's just say, for the sake of argument, that I have it in I8. Alright. So, and it's wired normally open. Right, so since I have it wired normally open, that is the correct configuration of zeros and ones. And this button will wait here forever at the beginning of the program to run. I need to put this wire back. Right, and now I would open my test interface. I would start my program running. Okay, and I'm going to show you what this might look like. I might have a 15 here. Right, and so it's going to start, and you see that it's waiting here. Now if this were real and I had constructed this system, when this happened, this would change to a 1, and now it would start to run M1. And you see M1 now is running clockwise. Right, I'm going to go ahead and let go of that again. And now it's going down, and let's say it goes down to 13. Still not there. 11. Still not there. Now when at 10, oh, the program terminated. Now I'm manipulating this in the simulation mode, guys. Remember, you would be getting this from a real system you had constructed and was running. Alright, so I have those things working now, and so I want to add the next step. I've done the first line, I've done the second line. It stops for 3 seconds. That's easy. You can do that, right? I want the motor to stop. I have to tell the motor to stop. Okay, I want it to do it for how long? 3 seconds. I gotta tell it 3 seconds. Put in a timer. Right click, change that to 3. Okay. Alright, and so now we're off. I'd open my test screen again, I'd start my simulation running, and I'd test that. When I had that working successfully, close it back. Alright, so now it's going to move back into the other direction until it reads 15 again. Alright, so I've got to put a motor command in again because I know it's got to go the other way. So it's going to go counterclockwise this time. And I want it to go that way until, I'm squishing everything up a little bit here. Okay, I want it to go that way until it gets back to the ultrasonic position that is represented by the number 15. So I need the analog branch again. Okay, I'm going to say it's ultrasonic and it's equal to 15. Okay, if it's no, Oh, that's too squished. There we go. Okay, and if it's yes, alright, I want the motor to stop. But that's going to be adding a couple of steps at one time, and we're still trying to do this simply, so I'm just going to put the stop man, and so I think I've programmed successfully to here. I'm going to open my test interface, I'm going to start my program, test, observe, see what happens, and try to correct if I have mistakes. Alright, but I knew that my program was running up to here, so it makes where the mistake is a small area to examine. Okay, and the last thing it says, wait until the operator presses the start button again to represent that another part has been loaded. So I can delete this altogether, and now this is just going to go back to the top. Alright, like this. Off we go. Now I would test again and be sure that my program works the way I'd like to, and then I'm good to go. But while it seems like that may have taken longer, it is much less frustrating if you have a mistake, if you do something incorrectly, and you don't see where it is. Hope that helps.